Hello, everybody, on the next meeting from agilelabs.pl. And today we have great pleasure. I'm very excited to welcome Troy Magennis, who teach me everything about metrics and Monte Carlo. And I'm so happy that we can have an opportunity to hear from you. This meeting will be recorded and then put on YouTube, but right now Troy will share these 10 disasters he experienced during working with forecasting, and later on we will have time for the discussion. So please make all the notes, all the questions you may have, because it is, I guess, pretty one in the lifetime opportunity to talk to Troy directly. So yeah, explore it. Don't avoid tough questions. And let's rock and roll, Troy. So the stage is yours.
No, listen, thank you. Thank you for inviting me. So if we were trying to choose what we're going to talk about, we settled on forecasting disasters because it's one of the things that I need to try and keep reiterating over and over again in forecasting or estimating or even doing any metrics work in our world, is there isn't one way of doing it right. So what I put together here is all the cases, or the first 10 at least, where I thought I was doing the right thing and I thought I was super hot at forecasting and it still went wrong, so that you can actually start to understand the cases and context of how and what methods might or may not apply in your cases. So yeah, I know we sort of normally do question and answer at the end, but I'm happy to take questions all the way through. So I'm using my disasters as a starting point, but if you have an example of where that is applied to you or a situation where it happened, jump in. All right. So I'm sort of just known really for the forecasting and metrics in the Agile world. I have some introduction material if you don't understand some of the terms that we're starting with here, Monte Carlo forecasting, and I have some simple spreadsheets to sort of help you out. But just quickly, the observable about what is Monte Carlo forecasting, I'm just going to show you that one quickly, because I think that it's important for you to understand why traditional forecasting, whether average story point, the sum of story points divided by average velocity, or the sum of story count divided by average throughput, giving us a duration in time to finish the remaining backlog, where it fits in our world of forecasting. All right. So the traditional way of working in our world of Agile, just do one thing here, is that we have a burn down chart. We start off that we have to do 25 stories or 25 points of work, and it really does not matter what unit of measure you want to use. The points or stories are interchangeable as far as the math goes. But the point is that if we have an average velocity or delivery pace that's faster, we finish faster. So if we could get 5 things done per week or per sprint, and we got 25 things total, it's going to take us 5 weeks to deliver. All right. If we add work, it takes longer. If we decrease work, it takes shorter. And this is sort of a very logical time and distance duration sort of calculation and computation that is commonly used in most forecasting of duration, Agile included. But the problem is, in our world, is can we be certain there's just 20 things to do? Can we be certain that our delivery pace is 5 points or 5 things per week or sprint? And the answer is no, we can't. There's variability in both of those numbers. And all Monte Carlo forecasting is the ability to do mathematics on ranges, on numbers which are uncertain. So in other words, what we want to do is that same division operator of the total work divided by the delivery pace, but rather than just 20 and 5 or 25 and 5, we want to sort of say between 20 and 30 divided by 1 to 5. And that's what was needed in mathematics, was a way to solve or approximate the answer to that problem, because there isn't a single answer to that equation. There's many answers, multiple answers. All right. So how does Monte Carlo work? What is this thing called probabilistic forecasting or Monte Carlo forecasting? Well, what it says is that starting with 20 to 30 points, delivery 1 to 5. The algorithm says pick a random number between 20 and 30. And in this case, we got 28. And then now, hypothetically, for every week or sprint after that, week 1, week 2, week 3, week 4, week 5, 6, 7, 8, 9, pick a random number between this delivery pace range, 1 to 5, and reduce 28 down by the random number that you get. Some weeks you get really very little done. Some weeks you get a lot done. Little, lot, little, that's my team. Little, and then a lot down to 0. And that gives us one possible result. It could take 11 weeks to deliver 20 to 30 points, delivering 1 to 5 story points per sprint. All right. But what Monte Carlo says is, what if we did that over and 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 over again? What might happen is we start seeing a pattern in some results being lower chance and some results being higher chance, happening more often in our simulations. So by the time I've done 500 of them, you'll start seeing that there's a sort of a neat pattern forming in the outcomes that are possible to occur. So that's great, Troy. What you've done is you solve this equation, 20 to 30 divided by 1 to 5, 500 times, and you have a set of results. So what do? Do I go to my boss and say it could take between 5 and 15 weeks? And they're sort of saying, I sort of knew that already. Like it's sort of somewhere between 2022 and 2027. That's not going to get you promoted quickly through the organization. You will probably, they will sort of say, go back and do more work. Because as humans, we get really uncomfortable that there are multiple possible outcomes. But in real life, that's exactly what's going to happen, depending on the decisions we make on the way through and features we cut and teams that get taken and borrowed elsewhere and teams which haven't been hired yet. There's all sorts of reasons why this one, the higher end, becomes more likely to occur than the lower end. But what Monte Carlo gives us is the ability to understand that these are all possible. And if we want to be absolutely certain that we're going to deliver by a date that we give because other plans are going to be made using that date, we can be more pessimistic or optimistic as we assume. Now, the point is 20 to 30, the average of that is 25, 1 to 5, average of that is sort of 2.5 or 3. But if we just use the straight division operator that we're using up here on the burn down chart, where do you think that the result we give other people would land? You want to put in the chat window, where would it land? Pretty much dead center here, right in the dead center, which means we would say 9 weeks. But there's a chance it could be 10. There's a chance it could be 11. There's a chance it could be 12. The chance it could be 13. And there's a really minor chance it could be 15. And that's the problem of our world. When we start doing mathematics just using averages, what happens is there are actual possible outcomes and even probable outcomes which will be more than that number. And that's what burns us. That's what burns our credibility with all of our peers, is that in simplifying and dumbing down the math, what happens is we get to a point where we're giving an answer that's on average right, but on average means half the results are faster than that and half the results are longer than that. And it causes chaos and pain in our organizations. So, but given that we're humans, and remember I sort of said it, the 50th percentile is what you're going to get if you do your math just on averages of velocity and throughput. We give a result which there's a lot of orange results which are beyond the result we give. So to convert our multiple sets of results into a single number, which our bosses like because that's how they roll, they're just like, give me false certainty just so I can go home at night and not drink. What we can do is we can choose a percentile, which is how pessimistic or optimistic we want to give the result to be. And, often it's around about 90% or 85% that we might give. So we would sort of say it's going to take 11 weeks. And what we've done is we've communicated a single number, which makes the bosses happy. But we've actually accounted for the variability that is natural in software development because it's sometimes bloody hard. And that's why we use sort of Monte Carlo. So nothing more than a way of doing mathematics on ranges of numbers. So whereas we would start with just a fixed total work divided by delivery pace, what Monte Carlo gives us is total work and delivery pace entered as a range or prior samples of your system and so forth. And there's nothing more to it than that. All that Monte Carlo does is it simulates uncertainty and away you go. Now, you don't have to do this by hand. We'll make sure the links get out there, and the links are in the slides there, but there's spreadsheets which just already do this. This is an Excel spreadsheet that just automatically does those same burn downs, but all you're really putting in is a start date, a low and high guess of the amount of remaining work to do, and a delivery pace, whether that's an estimate or if you have historical samples, you put them in and sort of change this combo box to say using an estimate to data. And what it gives you is you can opt into how much pessimism you want and sort of saying, I'm going to tell my boss the 5th of March because it's stupid US date format. It'll be in the format of your Excel, not my Excel. But either way, you're giving a value that otherwise you would have given a value of the 19th of February, and you would have been blamed for this variability and uncertainty, which isn't your fault. It's just part of the software development process. So the links to these are already here. So I guess what I'm saying is you don't have to do any of the work of worrying about what Monte Carlo is to get the benefit from it. But I wanted to give you just a quick background primer as to what it was so that my disasters make sense. We will continue from there. Any questions so far? Yep. Just in case they don't come through. Someone did that job, but I think I can do it here as well. I can put those in the chat window so that you've got a copy of them. Yeah, should you ever need them. Not saying you should, just saying they're there, and I'm going to be showing you how features got added to those spreadsheets based on disasters I encountered. On to the disasters. So it seems like absolutely obvious, right? That using historical data of the teams will be better than just using an estimate of how fast the team is going to run. So if I sort of say, give me the velocity. What velocity is the team going to run? And or what throughput? How many stories per sprint are they going to do? How many stories per week they're going to do? Or how many points they're going to deliver per sprint? It's irrelevant as far as I'm concerned here. Stick with me. But it seems like using data, historical data, would always be more beneficial than using an estimate of what the team can do. Well, you would think so. But in this case, what happened was the historical data that I used for forecasting, unbeknownst to me, was when the team was finishing off a prior release and they were working overtime, weekend, and nights. They discarded their family and they just worked hard to get the software product out the door so that Netflix could launch their latest player, right? And the problem is that meant that the historical throughput and velocity data that I used to do the forecasting was inflated. It made the forecast very optimistic and set the entire team up so they had to crunch the entire next quarter to hit the commitment that was made based on the forecast, based on their historical data, because the recent velocity and throughput samples for the next project took the samples from the prior project right at the end when they were crunching. So don't do that. You've got to find a way to make sure that you delete data if the team was not operating in a way that it was able to continuously operate in normal times. So you'd think you need a lot of historical data to be statistically accurate. You absolutely don't. You only need 7 to 10 samples of historical data to get up to 95% sort of accuracy. The math is out there on that observable website, and I'll make sure you get it. But 7 to 10 is a sweet spot of the right amount of data. But you must delete anything where the samples were captured when the team was under duress, because you do not want to base your next forecast on a team having to operate constantly under duress. And it's obvious in hindsight, isn't it? But depending on what methods you use in Scrum and everything like that, it's always just taking the average velocity, the prior 6 weeks of velocity, and summing them up. Well, oftentimes that's going to set your teams up for failure because they're going to be appearing to deliver faster than they normally can during that period of time. So 7 to 10 most recent samples, and delete any which are you don't think were indicative of how the team could or should be operating at a delivery pace. Anyone got any stories on this? All right. Yep, hit the delete key. That's the goal here. I want you, even if you're using historical data to base your math and your forecasts on, be vigorous with the delete key. All right, next one. This happens a lot, and I think it's a healthy thing that the teams, the size of story we talk about in the backlog often isn't the size of story that we code in. So the size of story in the to-do column are a different size, shape, and complexity than those in the done column. The problem is when we do velocity or throughput, it is based on the mathematics of the work in the done column. The things in the to-do column haven't been split by the developers or the team into deliverable chunks yet. And it causes the forecast to be wrong. So visual. When we start off, there's some features we want to deliver, and we get told to go away and come up with a forecast or an estimate of how long it's going to take to deliver those features. So we break some of those features down into stories, and then normally we would estimate those stories. All well and good so far. We use that, and we divide that by the delivery rate that the team's historical velocity is. Wrong. You can't do that. And yet this is best practice. This is taught in every Agile training course, is that you get the stories, you do planning poker on the stories in the backlog, you divide it by the average velocity or throughput, and you end up with a result. It will be a very optimistic result. Why? Because when the developers actually dig into these stories, triangle 1 story becomes triangle 1A and 1B. Triangle 2 story is coded as is. Triangle 3 story becomes 3 stories, 3A, 3B, and 3C. So the apparent throughput of velocity, if we based it on historical delivered work, will be 12. But we've only actually delivered 6 to-do column backlog size stories. So our forecast says we'll finish twice as fast as what we will. And I know it sounds obvious, but anybody who's doing a burn down chart is failing this test, because the denominator is using math and account from the done column, and the numerator is using math and account from the to-do column. And you need to make sure the two are correlated. Now, we don't want to stop the developers splitting the stories, because then we're sort of making them code too big an item, or an item which doesn't assemble it as Lego blocks the way it needs to do to go into production. So the splitting must occur. You must give your teams a chance to do this splitting. And you don't want to have to stop the team in order to come up with an initial estimate to do all the splitting up front. That's just a waste of time. But the simple thing is to just know what this split rate is. And this is not growth. It's just a miles per hour to kilometers per hour conversion. You're still traveling the same speed. It's just how you choose to equate and measure that speed. So you'll notice in my spreadsheets, I have this thing called split rate. And it sort of says that work is often split between the backlog size and the delivery size that we're doing. And if you don't know what it is, it's always 1 to 3. So the cases where it's not, the cases where it's closer to 1. If you're doing ticketing systems like password resets, where the person that gets the work does the work and the way it's listed is pretty much the size it's delivered, no splitting is going to occur. You can ignore this whole case. But if you're coding UI work that requires more investigation, examination, and a sort of a multiple tasks to deliver, it's going to be closer to 3. And if you just put a range in of 1 to 3, you're not going to be completely wrong. You're not ignoring it at all. So, but the point is, it's not growth. It's just miles per hour to kilometers per hour conversion. It has been in every forecast I've seen. Anybody using a burn down chart or a cumulative flow diagram to do regression lines about when you're going to deliver, suffering some inaccuracy based on this work. Anybody who's doing a sum of story points, dividing it by the average historical velocity, is definitely falling prey to this inaccuracy. And why is it bad? Because it gives us optimistic forecasts again, which make it unachievable, which mean we have to crunch more. You get the idea. All shades of bad. All right. Next disaster.
So, Troy, I have a question. If you can come back to the previous.
Yep. This one or this one?
Yeah, this one. No. With the table. Yeah, here. So can it happen? Do you use, because in here we can see 1.00, right, and 3.00. Yep. So can we actually use there some parts of the number? So it can be like 325, or actually it should be the whole numbers?
No, it can be partials in this one. So all that happens in the spreadsheet is I pick a random number between whatever you put there. So 1.25 to 3.8762. And then I take the backlog and I multiply it by that number. So it's a very simple implementation behind the scene. But yeah, I put 2 decimal places there to make it clear that you don't have to be exact.
Sure.
But in fact, yeah, I wish I hadn't. I wish I had made it just round numbers, or sort of said lots of splitting, very little splitting, or no splitting. Because what I'm trying to do is make sure people account for it at all rather than account for it accurately. But yeah, it can be partial numbers. I just somehow decided this one had 2 decimal places.
Yeah, I ask also in terms of actually how does it reflect the reality, right? Because task does not split into 1.5, 1.25. But basically 2 stories, 3 stories, and something like that, right? So I was wondering,
yeah, it's a very good point.
Reflect the reality?
Yeah, as I get older, I get less accurate on this stuff. So I'm more now sort of saying, tell me about how the backlog was created. Well, it's help desk tickets coming in. no splittings are going to occur. How much do you know about this work you're doing? Oh, we've never done this before. It's going to be a very high split rate, because as the team gets one story that's the right size to talk about, it's not the story that's the right size to code. And I tend to just think of it as like, so 1 to 3, 2 to 5, something like that. Like I actually have done something very different. If you look at the spreadsheets now, see, I now make you just sort of say whether it's clear and understood, somewhat understood, not really understood, and very unclear.
Yeah.
That does a very similar multiplication, because I found that people wanted to work out exactly what it is. But I think just using words helped me get through that. I just want to sort of say that this forecast is not going to be as accurate as the other ones, because we don't understand what you're talking about just yet, which is where split rate used to be a very backward way of dealing with that. So you can see where I'm heading. I'm heading to even take the numbers out, because it freaks people out.
Yeah, sure. Thank you.
See a number, it's got to be perfect, is the way people tend to roll. All right, team implementation. Yeah, so in this case here, what happened was everyone talks about what to do forecasting of throughput. Every story needs to be the same size. And in general, it's not true, because typically when we're coding, there's a distribution of sizes. Like we do 3 small, 5 mediums, and 1 large per sprint, or something like that. We tend to have already applied pressure on people to not have epics coded as stories. They tend to be broken down into semi-codable or discussable pieces of work. But there was a case where I relied on that being true, and it turned out not to be true. What turned out is at the beginning of the process, the beginning of a project, they did a lot of work to set up the architecture to implement a business process management tool. So the framework was very hard to get right. But once they got into just coding the tasks, like send an email, send a Slack message, send an SMS, delete a database record, add a database record, that sort of stuff, they were very short tasks to do. So at the beginning, their throughput looked like they were going very, very slowly, and they still had a lot of work to do. And it looks like this. When they started, they were doing all large pieces of work, and their throughput was 14. And all of a sudden, everyone sort of said, there's no way we're going to hit the deadline. We're not going to deliver on time. But once they got that framework built, there were these little XML files they had to write, or little bits of JavaScript they had to write to do each individual task. And all of a sudden, the size pattern changed. It went from being small, medium, and large sort of being a ratio of 2 times, 3 times, to being almost all small work. So when I got there, they were sort of saying, you need to come in and help us. We're looking like this project's going to be 6 months late. But when I went through the rest of the backlog, I sort of said, let's just do a quick scale on the sizing of the rest of the backlog. They were all very, very small pieces of work. So there was a lot of panic and re-estimating for no reason whatsoever. It was just that the size pattern of the backlog changed.
You're on mute.
Yeah, sorry, I coughed. So essentially, what I'm going to sort of say is size generally doesn't matter, but have a understanding where the distribution of sizes is going to change at the beginning, middle, and end of the project. All right. So, sorry, there was one question in the chat window there. Let me just quickly read that. How to use the tool when we develop products? 2 features, 8 improvements. Yeah, the question is sort of saying there is you've got multiple sort of types of things that you're trying to deliver, and they change. You would sort of know that as the type of work changes, you need to change as well. I have another spreadsheet there, which what it sort of does is let you, rather than do one forecast at a time, it lets you put in multiple features at a time. And in that case, what I would do is some of them that actually are much more complex and harder, I would sort of say that it's sort of not as well understood, or it's going to be split a lot more, and there's a lot more sort of work involved in it. So you certainly can do it, but what you've got to be on the ball about is that you don't have to worry about the subtask changing. You can still forecast at a level above it where it's just the story rate changes. And if sometimes, and it's commonly that you get some stories have are very well known and have a very fixed throughput of maybe we get 5 things done per sprint. Then there'll be others where you get sort of only 1 or 2 things done. That's why there's this range estimate of 5 to 8. It's to account for that you've got different types of work that you're doing over a period of time. So we actually, the reason we're doing this, the reason Monte Carlo is useful is that it allows you to account for this uncertainty. I still wouldn't change the split rate, but I would make sure that I accounted for that there are different types of work we do that have a very different number of tasks involved in them. And some allow us to get more done per sprint, and some force us to get less done per sprint. That answer the question? Was that just now? Okay. Yep. Yeah. It's more complex. I think I have one on size later on. This is very rare. This disaster here, it is mostly that the pattern of the small, medium to large items in your backlog is consistent throughout the backlog. But what you're looking for is that case where it's going to dramatically change and there's only small things left, or there's only huge things left. But even throughout a backlog, Justin, there's going to be the smaller things are going to be at the top and the bigger things are going to be at the bottom, because often they're just being more analyzed closer to the top they get.
So again, I have a question, or actually, question. So before we go forward, you mentioned that the size of task doesn't matter, and it is very, counterintuitive for people, and a lot of discussion around that. If you would like summarize in, I don't know, 2 sentences or 3, why this size of task doesn't matter from your perspective?
Yeah, no one will believe you when you say this. I think I have one in here about size. 1 second. Does size matter? So I'll put this in the window so you can read more about it. Okay. There are 2 possible cases. One is that the size of the work plays a major role in how long it takes to do something. And one is that the reasons work is delayed has nothing to do with the work itself, but to do with the system. So you wouldn't sort of say that now, where are you? Are you all in Krakow or Warsaw? Where are you all located?
Myself in Łódź, but the rest of people here, I guess, are distributed around it.
Nice. But either way, when there's a weather delay at the airports, it doesn't matter that your flight is only a 30-minute flight or a 3-hour flight. You're still delayed on the ground until that weather clears the airport. Now, if we were sort of saying that the delays or duration was just based on how far you had to fly, we would be wrong if we just relied on the distance of travel. It's how many connections you make, it's how much weather there is, it's air traffic delays, I don't know, it's countries doing special military operations in other countries, right? There's all sorts of reasons and factors that have nothing to do with your flight that cause the delays. Well, the same thing happens in software. So you could get yourself you could do a forecast that was completely wrong if you assumed that a 13-point story was going to take 13 times longer always than a 1-point story. Because if the delays in your process are dependencies or waiting for test environments, it's going to affect the 1 and 13-point stories pretty equally. And what ends up happening is is if we look at the cycle time versus the story point estimates on size, there's huge overlaps in how long it takes to deliver things based on factors outside of the work itself. So if we're going to base our forecasts on size, you better be certain that there is some correlation between the 13-point size taking 13 times longer than a 1-point size. And in systems which have low process efficiency, which is the hands-on time versus the idle time, that's not true. So I've seen forecasts be incredibly wrong, assuming that size matters. And I've seen forecasts being wrong, assuming size doesn't matter at all. So at a team level where you have very few external dependencies, estimating using points and size may give you value. Working out capacity for a sprint and so forth, absolutely good use of size. But zooming out to a feature level where there's multiple stories of multiple sizes and dependencies on other teams and environments that have to be coordinated and data migration, the size will add error to the forecast. And you're better off taking a bet that there's a distribution of sizes in all of the 15 to 25 features, 15 to 25 stories that you have. So that's going to give you less error than assuming that a 13-point story is going to take 13 times longer than a 1-point story. So if in doubt, do a forecast using both and discuss both. After you've done it a few times and you've had a few examples of real outcomes, pick the one that's working best in your environment. 8 times out of 10, that has been throughput for me, because the touch time is so small in our development environments that thinking that the size of the typing time is going to be the biggest impact on the forecast turns out to be wrong. It adds more error than I expect. So it seems counterintuitive. Of course, the size of the work matters, but the system often matters more. And throughput is a measure of pace through the entire system, not just how long it takes me to code it. Does that make sense?
Yeah, brilliant. Thanks.
You're not going to win any friends, but I think the only thing you can do is forecast using both, and then pick the one that gives you better results in your environment. Oh, here's a classic one. This one was a classic one where the team was updating a credit rating system for a country. Yeah, it's good to be them. But the problem was that there was some contractual language that said the system could not go live until it matched the identical results to the credit rating in the old system. So imagine that you're setting to do a nice small product upgrade, security patches, adding a few new features, but you can't go live until I think it was sort of 80 million citizens got exactly the same credit rating through the new algorithm and the old algorithm. That took 18 months. So the 3-week upgrade took 18 months and 3 weeks because it got done, but they weren't allowed to disband the team until they chased down every single credit rating difference, starting off with a list of a couple of 100,000, getting down to 3. And for the last 3 months, they were trying to work out why 3 citizens got a different credit rating in the new system versus the old system. Now, you won't encounter anything this massive, but think about things. If your software process needs someone else to approve that it's allowed to go to production, or a legal document needs to be approved to sort of say, yes, the privacy statement can be updated, the time that you're forecasting to you're done for approval is not going to be what other people see as the delivery after approval. So you need to make it very clear. We are forecasting to the point of where it is going for approval, or we are forecasting to the point where legal is going to sign off on the language of our work. So you need to make it very clear the point that you're forecasting to and where it stops. because they accurately forecasted how long it's going to take to do the upgrade of code. They did not forecast accurately when that code could go live, but they're judged against go live as far as you guys suck at estimating. So you've got to be very clear about where your boundaries are of forecasting. All right. Next error. Well, what was this one? I'm trying to remember this now. One of the biggest causes of the forecast not hitting actual is the fact that your team gets borrowed. You know, people always tell me, oh, Troy, we've got excellent developers. Our coders, our testers are the most brilliant people. We've got all the best sort of architects and whatever. And I should say, well, that's a pity. And then, what do you mean that's a pity? Because if people are known to be the experts in an organization, they're always borrowed by other people. So the moment that there's a production incident, the moment that there's a new team rolled up, brought into the company, they're always stolen from you. So one of the worst things you can have is the experts on your team, because what's going to happen is those people are going to be borrowed and your throughput is going to drop to zero. So much so that I now have the team focus on this work in all of my spreadsheets, where I can sort of say in advance, let me say that half my bloody team is going to be stolen by someone else at any moment in time. Because if you don't upfront assume that your team won't only be focusing on this work, your forecast, well-meaning, will be assuming that you've got your team, but your team will not be the team that you're coding with. So so it's a very important thing to negotiate. And I normally sort of say, well, they say, well, we need more. Well, what can you do to protect my team? Because if I made my team 100% on this, you're going to get feature 1 and feature 2. So it helps you make the story narrative of how important it is to have a team that is dedicated to your work. And you'll see that on all of my spreadsheets now. You know, I have an entry about how dedicated to this work this group of people are, and it helps build that narrative around my stop stealing my team, leave my M&Ms alone, they're mine. I want my candy, don't take them. So so you've got to be thinking about what else do your team members do, and how likely are they to be stolen to do that during this project forecast schedule and timeline. It will never be zero, but your job is to make sure that you at least account for it. So no amount of estimating, no amount of sitting down doing story point estimates and forecasts could absolutely sort of allow you to account for those external factors of there's a production issue, there's a global pandemic, just a random example, right? There's always going to be external factors that are more important than the work that you're doing. And that's why I'm not sure that the time spent doing planning poker and detailed estimation of work pays dividends, because I find the external factors cause more impact to the delivery pace than the actual story count itself. And this is the thing that we spend all this time estimating the size and amount of work we have to do. And then the delivery pace, we do an estimate, or we do an average velocity, or we do something very simple with that. But external factors are what causes our pace to vary. And we need to really, that has a much bigger impact on the math than the original size. Because remember, we did the algorithm before where how many times in the algorithm I showed you for Monte Carlo did we come up with a random number for the amount of work we have to do? Just once, right at the very beginning. How many times did we calculate and simulate a random burn down point? One for every sprint or week in the forecast, every sort of 500 simulation runs. So there's a 10-to-1 ratio of the sensitivity of getting the delivery pace wrong. But everyone spends all their time on getting the amount of work and size right. But if you did the math, if you played the math out, a 10% error in delivery pace is 100 times more impactful than a 10% error in the initial scope size. So to get your forecast right, what you really got to do is you've got to be understanding delivery pace more than understanding the amount of work you have to do. And external factors are the biggest ones that we have. So here's a classic external factor. HR policies. Use your annual leave by end of year or lose it. There's throughput for 100 teams. Notice something? The HR policy meant that we're doing 600 things a week to 0 for almost a month, for 3 weeks. That delivery pace excursion sort of matters, because if you started your project here, God help you. If you start it here and it finishes here, it doesn't impact you. But depending on when you started the project in the year and which quarter you were in, depended just how impacted you were by this stupid HR policy. I calculated the cost of that, and that's about that little HR policy, that little word, use your annual leave by end of year or lose it, pretty much cost this whole organization $800 million. Because the cost of delay of a month's worth of delivery work and missed schedule, and really having the remaining people who were at work unable to work because they were the people who didn't take their leave through the year were the constraints. So now the constraints went away, nothing got done anywhere, which is why it drops to 0. And it's not like you had this huge burst of throughput when they returned. They were so central to actually flow of work that it's just like this time never happened. It was just like everyone went to sleep. It was Snow White. They just sort of went and collapsed onto their desk with their heads down and did nothing for a month. So nothing you can do doing planning poker or estimation could be as bad as a bad policy in managing people and pace. So people and pace are the things that you're looking for. They were shocked about this. They sort of said, no, your data must be wrong. Well, I said, well, it's not my data, it's your data. And it comes out of the same system you're doing. Can you find other data? No. Oh, okay. I mean, they changed the policy to sort of say, rather than at the end of the year, it was the calendar year of where you started with the company. So they distributed the annual leave throughout the year. Very simple change, very big reward. All right. And here's another one, another external factor of the historical pace. It's about that often companies we deal with have periods of the year where very little gets done by design or by happenstance. So I worked with a couple of companies who have a customer conference, Salesforce, Tableau, Oracle. All those companies have a big company conference. And leading up to that conference, everyone's working hard to get the demo working for the keynote. And then during the conference, no one's focused on their work. They're all helping customers or they're at the conference. Either way, velocity and vacation time is delivery pace is not linear throughout the year. And you've got to account for it or help your organizations at least understand it. Oops, sorry, where am I? Chat window, let me just go over here. I mean, I have a very blunt instrument in my spreadsheets, but I think the conversation is more important than the math here. All right. When do you all take vacations? When's everyone off?
July, August.
All right. So the pace that you had in June, how much lower do you think your delivery pace is in July and August?
Let's say by half.
Yeah, I mean, the Australia case, in December, it's 0.5. It's thinking about being drunk. And January, it's 0.1, hungover. Either way, these changes in what your throughput or your velocity is not due to the work, it's due to the system again. And what we're trying to do here is just preempt that that's going to occur, so that we don't build into our forecast starting in November and realizing that by February is really when we're going to get it started. That's when it's going to be done. So it doesn't have to be accurate. The thing is I don't want developers blamed for things which aren't their fault. I want this to be understood that this is a system dynamic that is going to occur. So maybe don't have all of your development teams in a market where they all take vacation at the same time. Spread them out across the world. We've sort of been learning to do that recently by working remote and stuff like that in many countries. Use it to your advantage. Don't pick a country which goes on vacation in July and a country which goes on vacation in December, and distribute your teams so that you've got coverage in all areas of skill set at all areas of the year, so that you can sort of flatten out your distribution curve. Why did I get forecasting error 10 and then I went back to 7? Anyway, I thought I was done. Any questions? Any other questions on that so far? Yeah, 30% July, August. I agree. It's going to be quite low. It's going to be lower than what you expect it to be. But you can start measuring it. Just grab the throughput of every team. Oh yeah, these are very quick now. I think I moved that one up. That used to be my number 10, and I found it being a very common one, so I moved it up into 0.6, but didn't change the number. Here's a classic one. The number one error in forecasts. Let me just pick this one, this spreadsheet. Which input is the largest error of any of these inputs on this sort of forecasting spreadsheet? Think about all the inputs we have there. So we got how many stories to be completed, the date that we start, how the stories get split, the throughput or velocity, how much the team's focused on it. Which one causes the most error? Someone's been to my stuff before, yeah. The start date. The start date, if your start date matches the calendar, beginning of a month, beginning of a quarter, the assumed end of a prior project, it is always wrong. And it's wrong for a number of reasons. One is the prior project doesn't finish. One is the team's not hired. And the thing I get is that we get told to do the forecast, which is where the people go off and then they sort of need to approve the budget. But the approval of the budget and the hiring of the people happens way past the assumed start date that we were given to do the forecast, right? So in this case, they took 2 months to, the numbers were approved, but finance had to allocate the funding, so we couldn't hire the developers or the test teams, and we couldn't get started. So yeah, be very careful giving a start date. In fact, what I've done in these spreadsheets is I allow you to do that. Refuse to give a completed date until the definition of what means a start date is done. So by deleting the start date, what you're talking now, it's going to take us roughly 15 sprints or 15 weeks to do this feature. That is good enough to compare options and to make a decision about for funding. And it does it without actually going on the record with a number which is going to stick in their goddamn heads, and that's what they're going to hold you to. So one of the things I added recently was the ability to do that, and I suggest you do that. You don't give people a completed date until the start date is really nailed down and known. Yeah, so that's the other thing is dependencies are going to get you burnt, because if there's multiple teams that require work and you're not working on the most urgent feature or the most urgent piece of work, you will not be able to forecast how long it's going to take to go through multiple teams. The only thing that you can really estimate accurately is the time it's going to take a production outage to go between team 1, team 2, and team 3. If you've got something that's just of a medium, normal to low priority, and that team, the middle team, is taking work from multiple places, you cannot know where your story is going to fit into their stack ranking of the work they choose to start in advance. So in a dependent environment, you're going to struggle to know that there's how long it's going to take to move through multiple teams, unless it's the most urgent critical work. It's just going to be something that's near impossible for you to do. So I have no solution other than you just have to make that clear. I can tell you how long it's going to take once each team gets it, but what I don't know right now is how long it's going to sit before that team is able to start it. So I give a forecast of a set of individual durations, and sort of saying, if you can make sure this is picked up the moment that we're finished with it, I can give you an estimate of duration. But you can do duration at a team level, but you cannot know how long it's going to sit in someone's backlog if it's not the most priority urgent work. Yeah, now this is one thing I have learnt in my past. Stick away where you can from giving dates. I have one of the Monte Carlos there, which you give it a target date, and don't delude yourself. There's always a target date in someone's head. When they ask you to forecast, they're not really asking you to forecast. What they're trying to do is they're sort of saying, I have a date in my head. I want to know how close your date and my date align. That's what they're really doing. So if they won't give you a target date, make one up. But what we're really negotiating here is what we can get done in a period of time. So let me just make this, let me just get this up a bit to give us a bit more leeway there. So what we're trying to do is understand what's going to miss. It's not what's going to hit, which is of interest to people. It's the first feature that they're not going to get. Because what happens when things hit the fan near the end of projects is scope gets cut anyway. What you're trying to do with forecasting is make sure you start work in the right order, not finish it. It's a starting problem. So what we're trying to do here is when they sort of say we need feature 3, we're sort of saying, well, how much do you need feature 3? Well, it's really critical. More critical than 1? Yes. So I'm going to sort of say, well, then let's swap the order of those. So now you're definitely going to get feature 3, but you're not going to get feature 1. Huh. Well, I need a bit of feature 1. Did you need all of feature 3? Well, no, I didn't need all of feature 3, come to think, but I just needed this part of feature 3. How much of feature 3 do you need? Well, I need this first part, about 3 to 8 points there. Oh, that's probably a bit bigger story. So, okay, well, that's good. So now you get feature 1, and you get feature 2, and you may even get feature 3, but it's right on the borderline. So what we're trying to change forecasting into being is a better design of the order and the size of the features we start to get as much value as possible by the date we need. We're not trying to give people a date so they can do it in their head. Is that less than or larger than where I needed it? That's not what we're trying to do. That's what's going to happen when we give it to them. A better conversation is around the start order and how to split work into the absolute must-haves to get as much of these features and the valuable parts of those features delivered by the target date. So I try and guide my people down the road of designing the start order and splitting the features into deliverable pieces as early as possible, deliverable chunks. And that's it, because I did the number 10 as number 6. Apologies for that, but you get the point. I love this stuff, as you can tell. There's never one way of formula of doing this stuff. I'm just trying to give you, over time, the things I've learned and the things that's screwed up my forecast, so that I get better and you get better over time. But with that, I know we do Q&A. Hopefully I haven't taken too long.